Right, students, so we are back once again. In the last lecture we saw how nitrobenzene was formed from benzene. Now we'll proceed further with the production of meta-dinitrobenzene from nitrobenzene. The mechanism will remain the same. But the only change that we will observe in the reaction is how meta-dinitrobenzene can be formed from nitrobenzene. Of course, benzene to nitrobenzene to meta-dinitrobenzene. So we will learn it in 2 episodes. In the first we learned benzene to nitrobenzene. Now we will take nitrobenzene to meta-dinitrobenzene. For that, I'll first write nitrobenzene, and as you know, as we have seen in the previous episode, that for nitration reaction we required 2 reagents: the concentrated nitric acid and concentrated sulfuric acid. Now in this reaction you can see the nitro group is already existing in nitrobenzene. So when nitration reaction will be carried out, at that time the nitro group will be definitely formed. That is HNO3, which is a weak acid as compared to sulfuric acid, will act as a base as we saw in the last episode. Same thing will happen over here. So nitric acid will once again form OH minus ion, because you know it is a base and base always has a tendency to lose OH minus. And as a result, NO2 plus will be formed. We talked in the last episode that NO2 plus is an electrophile. It is also known as a nitronium ion, and it is an electrophile. Whereas as far as sulfuric acid concerned, this sulfuric acid, being a strong acid compared to nitric acid, remains acid, and so it loses a proton. According to Arrhenius acid-base theory, a compound which loses a proton is an acid. So it loses a proton, so what is left out is HSO4. H is plus, so HSO4 is now minus. Now, this nitro group which is already present on benzene, it has got the directive effect. Please listen carefully. The compound which is already present over here, it is nitrobenzene. In nitrobenzene, the group nitro has got the directing effect. What is the directing effect? See, whenever the incoming group comes into the compound, enters in the compound, it is always the existing group which has got the tendency to direct the incoming group on. There are 3 possibilities of the positions, as you know. One is known as ortho, one is known as meta, one is known as para. P-A-R-A, para. What is ortho? When, I'll explain you. When, suppose this is a benzene ring. When a group, let us just simply write a normal group, not actual group, but it's a supposition. Suppose A group is present on benzene. Then this A group has got the directive effect. It will direct the incoming group. Whatever the group is, incoming group will be directed according to the present group A. The existing group A will direct the incoming group on three possibilities. One, if it directs the incoming group on the adjacent carbon atom. Let us say the adjacent carbon atom with respect to this is this, and so the incoming group, let us say, is A dash. Then these positions adjacent to each other are termed as ortho if they are adjacent to each other. Instead of that, if the group A is present on the carbon, as you can see, and if the incoming group gets onto the third position with respect to the first, this is 1, this is carbon second, this is carbon third position, then the incoming group is settling over here. This position is known as meta position. And if with respect to the existing group A, if the incoming group is placed exactly on the opposite carbon atom, you can say it as the fourth carbon if this is the first, second, third, fourth, or first, second, third, fourth, both the ways it is fourth carbon or opposite carbon, then that position is named as para. So we have three positions for the group to get into the ring: ortho, meta and para. Now we come back to our topic. The existing group is a nitro group. Nitro group is an electron deficient group. It is an withdrawing group. It has tendency to withdraw electron. It is lacking electron, so it is electron withdrawing group. As it is an electron withdrawing group, it has a tendency to direct the incoming, whatever the group is not concerned. The incoming group has got no ideology. Forget about that. Don't worry about that. Think only for the existing group. As it is electron withdrawing group, it will direct the incoming group, mind you, always and always on the meta position, that is the third position with respect to itself. So this is position number 1 of carbon, this is position number 2, and this is position number 3. So now the incoming NO2 group will get directed on this position. This position with respect to the existing group is third position. So now the compound is named as meta. Meta can be written as M, it is understood as meta. And now we have two nitro groups. So it is di-nitro, and basically the compound is benzene. So the compound is named as meta-di-nitrobenzene. This is how the product is formed. But you can see the nitronium ion, the concept remains the same, the mechanism remains the same as of the previous episode. The nitronium ion is electron deficient group. It is an electrophile, electron lacking group. So it is getting towards the benzene nucleus, which is rich with electron. There is a pi electron cloud above and below the plane of benzene. So it gets attracted. But this time it has to get onto benzene depending on the existing group which was already present. It cannot just simply settle on second, third, fourth, whatever it likes. No, it is existing. The situation depends on the existing group. So this group is meta directing. That's why the incoming group is directed onto the meta position. So we get meta di-nitrobenzene. Now that group is settled over there. How it has settled, we have talked earlier in the previous episode. The H which was bonded to the carbon leaves the carbon, leaving its electron, and as a result that H attains a plus sign. It's a proton now. The carbon where from H has left, that carbon attains a minus sign. So this carbon is minus, NO2 is plus. So that plus and minus nullifies, and as a result NO2 settles on carbon, forming a bond. Fine. The H plus which has left the benzene ring comes and joins with HSO4 minus of sulfuric acid. And that H plus and this HSO4 minus combines together, and that originally gives you concentrated sulfuric acid. That's why we would say that here in the reaction, sulfuric acid acts as a catalyst. It is an acid, but it remains as a catalyst. It is obtained back once the reaction is over, and the byproduct obtained is water. So this is how you can see the whole nitration reaction of benzene is carried out, where in the first, or I would say the last episode, we talked the formation of nitrobenzene from benzene. In this episode we have talked formation of metadinitrobenzene from nitrobenzene. So this is the whole scenario, where in short a superficial study we have also taken for the positions of the two groups, ortho, meta and para. So I think you have understood what is the concept of the reaction and what is the position placement of the incoming group in this reaction. I hope you all have understood it in a better way. Do remain with the topics. There are many more topics uploaded on the same channel. So wherever and whenever you have doubt, just click onto the channel, get onto the topic, and if otherwise you have any doubt, do comment in the same video. I'll try to sort out your doubts there as well. Moreover, you can also note my email. I'll write over here. It is styrene, STYRENE 1114 at gmail.com. There also you can raise your suggestions, you can raise your questions, but the best way is to write a comment, write a question on the same very video so that I can answer your question. Thank you so very much. Stay tuned on the same channel for any topic regarding chemistry. Thank you. Goodbye from now.